Hi, I'm Edouard Machery, and today I will be talking about the Amodal brain. The issue of interest has a long history of philosophy, and it divides, on the one hand, people like Descartes from people like Hume. So Hume, for example, thought that concepts and percepts are qualitatively identical. You may have quantitative differences between concepts and percepts. Percepts may be more vivid than concepts, for example, but at the end of the day, concepts and percepts are the same kind of representation. On the other hand, people like Descartes, amodal theorists, believe that concepts and percepts are two distinct kinds of representation. You have a qualitative difference between concepts and percepts. Now, that debate has been alive throughout the history of philosophy and also throughout the history of psychology in the 19th century and 20th century. It's fair to say that nowadays empiricism may well be the dominant view in the psychology and neuroscience of concept. In psychology, you have people like Barsalou, Glenberg, and Mendler. In neuroscience, people like Damasio, Martin, or Thomson-Schill. In philosophy, people like Prince, who have defended modern versions of Hume's empiricist views about concepts. Today, I'm going to be focusing on the articulation of the empiricist idea developed by psychologist Larry Barsalou on the right of the screen and philosopher Jesse Prince on the left of the screen. One way to introduce or to frame the issue today is to look at an old quotation by Barsalou and colleagues in 2003 in Trends in Cognitive Sciences. In that quotation, Barsalou acknowledges that there are theoretical, philosophical arguments for amodal concepts, but argues that there is in fact little empirical evidence for amodal concepts. And he adds that in fact, since the 1990s up to nowadays, we may say, empirical evidence has accumulated for modality-specific representations. What I want to do today is to challenge Barsalou's claim. I want to be arguing that there is in fact a large amount of evidence for the view that the brain is an amodal system and that the evidence for empiricist approaches to concepts is in fact weak. So the conclusion of this lecture will be that the conceptual brain is an amodal system. The structure will be organized as follows. First, I will say a few more things about the contrast between neo-empiricism and amodal theories of concepts. Then I will very briefly highlight what I see as the limitations of the evidence for neo-empiricism. Then I will review the growing body of evidence for the hypothesis of an amodal brain. And then I'll come back to defend what I call the offloading hypothesis. Right, let's start with providing more details about the contrast between empiricist or neo-empiricist theories of concepts and the hypothesis of an amodal brain. The following quotation by Jesse Prince in 2010 from a paper in Mind and Language may be helpful to get us started. Prince writes that to think about a category, empiricists will say, is to simulate an encounter with that category in a sensory way. Because categories look different in different circumstances, simulating an encounter requires drawing on a wealth of knowledge. These sources of information are all very different, but they share several things in common on an empiricist picture. They are all made up of sensory representation, they are all acquired through experience, and they are all drawn on to create temporary simulations in working memory. So today I will not be concerned with Prince's claim about the acquisition of concept, namely his anti-nativist view. I will be mostly concerned with the view that concepts are made up of representation and to think is to create temporary simulations in working memory. So the view I'm targeting is made of the following two claims. First, the information that is stored in a concept is encoded in perceptual representational codes or formats. Second, conceptual processing consists in reenacting perceptual states and manipulating these perceptual states. Let's focus on each view in turn. So let's focus first on the claim about the information that's stored in a concept. The view that we have is roughly, the contrast that we have to deal with is roughly the following one. Let's start with perception. There is an event in the world. There's a dog, for example, that barks, and you see the dog and hear the dog. There's an episode of transduction in your sensory organs, and this transduction results in the creation of vision-specific representation and audition-specific representations in one or many perceptual formats. Vision-specific perceptual format, audition-specific perceptual format. If you are an Amodal theorist of concept, you believe that there is a process of translation from this vision-specific representation, auditory representation, to a distinct format, a distinct language, namely the format of concepts. In long-term memory, there is a creation of a concept in a new format, a format that's distinct and irreducible to the auditory, visual, and so on and so forth, more generally perceptual, representational format. By contrast, if you are an empiricist, you're going to think of the creation of a concept as a process of selection of some of the perceptual representations by means, for example, of attention. Right? So the creation of a concept is not a process of translation into a new format. It's a process of selection of some of the perceptual representation to store them in long-term memory. What about the second claim that is constitutive of the neo-empiricist view of concept? It's a claim about thinking. It's a claim about what it means to think to solve tasks or problems. On that view, thinking consists in reenacting a perceptual, a visual, sensory, sensory-motor, auditory representation. So what one does when one thinks is access a long-term memory, which is made up of perceptual representations, and in a context-sensitive manner, select some of this perceptual representation to reenact a perceptual state. Right? So that's a sketch of the empiricist view of concept and its contrast with the Amodal view of concept. Now it's clear that to lay out this contrast, I've been appealing to the notion of a code or a format. And it would be fair to ask what's a format and how are formats individuated. Now it is striking that both in cognitive science and in the philosophy of cognitive science, there has been very little work on this question. And in fact, we have very few insightful articles to use to answer the question, what's a format? So one thing we can do is start with intuitions about same versus distinct formats. So we may say, for example, that binary notation versus decimal notation of integers are, in fact, two distinct formats. We may also say that a word expressed in English and its translation in French are two distinct formats. Dog and chien are two distinct formats. Or to use artificial languages, a concept in BASIC versus a concept in Fortran would be expressed in two distinct formats. And then there are these borderline cases for which we don't have a very clear intuition. Is English, when it's written and when it's spoken, two distinct formats, or do we have to deal with a single format, is an open question. So maybe one way to start working on the notion of format would be to start with these clear cases and also with these vague cases. Furthermore, it's clear that the properties that define formats are not semantic, right? So binary versus decimal notation have the same semantic power, but they are same expressive power, but they are two distinct formats. On the other hand, it's not the case that every non-semantic property of a token representation individuates a format. So for example, look at these two ways of writing the word cat. The distinctions here between these two ways of writing the word cat is not semantic, but nonetheless, we probably would not say that we are dealing with two distinct formats. Right? Now, at this point of the lecture, we are in somewhat unpleasant situation, right? To spell out the contrast between, on the one hand, empiricist theories of concept, and on the other hand, amodal theories of concept, we appeal to the notion of format. But beyond some intuitions about clear and vague cases, and beyond some basic but insufficient principles about what type of properties individuate formats, we do not have a complete theory of format. The good news, I believe, is that we can make progress in this area as in other areas without specifying the notion of format entirely. So it's the same situation as we find in linguistics. So in linguistics, we do not know how to individuate languages or dialects, but we can still make progresses. The same is true in psychology and cognitive neuroscience. We do not know how to individuate representations, nor do we have a theory of what a representation is. But we can still make progress in psychology or cognitive neuroscience without having a complete answer to such foundational questions. I suggest that the same is true. Let's try to make progress without having a full theory of what a format or a code is. Now, there are answers about what a perceptual code or format is in the literature, about what distinguishes a non-perceptual code from perceptual codes. I want to look at two answers, both of which are problematic. Barsalou, in a few papers, has argued that perceptual codes are analog, while amodal codes or amodal formats are linguistic. That's a distinction I want to reject as a way of distinguishing perceptual versus non-perceptual codes. I want to leave it open for some amodal representations to be encoded in an analog format. The second suggestion comes from Prince, who has argued that perceptual formats just are the formats used by perceptual systems. He argues for that view in his first book on concepts. Again, I want to set aside these proposals because until we are told what a perceptual system is in the mind or in the brain, that solution will not be extremely helpful. So then, what's a perceptual code? Well, the good news, I believe, is that we can bracket this question. We can bracket, at least for the time being, the question of what makes a code a perceptual code. What we need is, at least for the time being, is instead of an answer to the question what is a perceptual code or what makes a code perceptual, what we need are plausible tests for whether the representations involved in solving a task are perceptual. And I think what we have in the literature, in psychology and in neuroscience are actually a set of such plausible tests. So let's start by looking at some examples. So there are behavioral tests and neuroscientific tests. Some examples of behavioral tests that suggest that the representation used in a given task is perceptual are the following one. Transfer cost. Let's suppose, for example, that you are trying to solve a task involving concepts in a given perceptual modality, right? So you are thinking about, for example, visual things, colors, for example. And then you are asked to think about sounds. The empiricist view of concepts predicts that switching from one modality to the other modality in thought will involve a transfer cost compared to remaining in the same modality. Another behavioral test concerns facilitation and interference. Because thinking on an empiricist picture involves using perceptual representations, the use of other perceptual representation in concomitant tasks will either facilitate the solving of the resolution of task involving concept or interfere with such resolution. In addition to these behavioral tests, we also have neuroscientific tests. The localization of brain activation in task involving concepts will be relevant for deciding whether or not concepts have a perceptual nature, right? To the extent that they involve early brain areas involved in perception, the evidence will be supportive of an empiricist picture of concepts. Furthermore, the empiricist picture of concept is committed to the view that the brain systems involved in conceptual thinking are many. They are widely distributed. right? So to the extent that we find fewer, to say nothing of a single brain system involved in the activation of concepts, that would be evidence against an empiricist picture. Now, what we want is to use this test and other tests to find convergent evidence that the representations involved in activating concepts and solving conceptual tasks are of a perceptual or a non-perceptual nature. None of these tests is definitive of what it means to have a perceptual representation or a non-perceptual representation, but convergence with a such test would provide strong evidence for the view that concept and percept are of the same kind as empiricists wanted or of different kinds. Alright, so what we've seen so far is a way to spell out the difference between empiricists and Amodal theorists about concepts. That difference requires a notion of format, and I've argued that we do not have a theory of format at hand, but I've argued that we can do without. It also requires a theory of what makes a format or a code a perceptual code. We do not have such a theory, but I've argued that what we need is, instead of a theory, convergence between plausible tests that suggest that the representations involved in a conceptual task are perceptual or non-perceptual. Now I want to move on to Basalou's claims that there is actually a lot of evidence in support of the view that concepts have a perceptual nature. I will not spend too much time on this area since I've argued already at length for this view in a paper published in Cognition in 2007. But I want to highlight what I think are the crucial issues for the type of research that Basalou and colleagues, as well as other psychologists and neuroscientists, have been doing since over the last 20 years. Focusing first on the behavioral evidence and then turning to the neuroscientific evidence. Let's focus on the behavioral evidence first. I think there are two main issues for the type of behavioral evidence adduced to by psychologists. First, there is what I call Anderson's problem. The issue here is that Amodal models of concept do not make a single prediction. Rather, depending on the specific details of the Amodal models, they make distinct predictions, some of which are identical to the predictions made by Basalou and colleagues. The outcome is that the findings of Basalou and colleagues do not bear against Amodal theories of concept in general, but just against some specific Amodal models. And that issue has been overlooked by maybe 20 years of neo-empiricist research on concept. The second issue is what I call the imagery problem. Amodal theorists like me or like Jerry Fodor do acknowledge that we often use imagination or imagery to solve tasks. So just showing that perceptual representations are used to solve a given task does not provide evidence against an Amodal approach to concepts, right? It should be found in a task where Amodal theorists like me and Fodor expect people not to be using imagery. And again, that issue has been overlooked by psychologists working on concepts from an empiricist perspective. Let me say a few words about the neuroimaging research, highlighting one claim made by Basalou in the TICS paper I've already mentioned, and in papers published since then. Basalou and colleagues, as well as other neuroscientists, have argued that when one looks at brain activation in a task involving concept, what we find is that this activation is found in modality-specific areas, in perceptual areas, and that's taken to be evidence for an empiricist approach to concepts. However, when one looks more closely at the evidence, in many, also admittedly not all papers, in many papers, the areas involved in thinking are near and sometimes overlaps, but are rarely identical with the areas involved in perception. So the evidence coming from neuroimaging is actually much less clear than what Basalou and other cognitive neuroscientists are prone to say. I will leave it at that for the limitation for the evidence for neo-empiricism. What I want to be spending more time, maybe the next 10 minutes, is highlighting the growing body of evidence for the hypothesis that the brain is, at the end of the day, an amodal system. And I will be looking at three kinds of evidence: behavioral evidence first, neuroimaging evidence then, and finishing with some neuropsychological evidence. So let's start with some behavioral evidence. The most compelling case for amodal representations in the brain comes from what is known as a number sense, our capacity to make judgments about the approximate numbers of objects in a set of objects or in a sequence of sounds. What we've learned now for decades about this capacity is that it obeys Weber's law. As the number of objects increases, the mean assessment remains accurate, but the standard deviation increases, as you can see on the slide. What is striking about Weber's law is that it is found both for estimating the number of objects in a visually presented set of objects and the number of sounds in a sequence of sound. Now, the view here is that the best explanation of this phenomenon, that the same law applies to the two performances, is that there is a single amodal cognitive system involved in representing the number of items either in a visually presented set or in a sequence of sounds. Furthermore, what we've also found is that there is very little, if any, transfer cost in adding quantities within and across modalities. And the lack of transfer cost again suggests that there is a single amodal system instead of many perceptual systems involved in estimating the number of items in a sequence of sounds or in a visually presented set of objects. Now, this conclusion from behavioral data is confirmed by evidence coming from neuroimaging. So one thing that we've learned is that the estimation of the number of objects involves a network of brain areas, and a crucial piece of that network is intraparietal sulcus, IPS. In recent work, people have examined whether or not the network of areas involved in assessing the number of objects varies across modalities. And here is a paper by Piazza and colleague in 2006 where they report the relevant evidence. And here is what they conclude. Results show that attending to approximate numerosity correlates with increased activity of a right lateralized frontoparietal cortical network, and that this activity is independent of the stimuli presentations modality. Let's look at the data. What you can see on the panel A, if you look in particular at 3, that would be the IPS, the intraparietal sulcus, you can see that activation for the visually presented stimuli and activation for the auditory presented stimuli is actually extremely similar, right? Suggesting that the representations that are involved in estimating numerosity are in fact independent from perceptual modality. They are amodal. Now, one may respond at this point of the lecture that I've been mostly focusing on concepts of numbers, and it may be that number representations are amodal, while everything else happens to be perceptual, all other concepts. Evidence suggests that it's not the case. Let's look, for example, at neuroimaging evidence about concepts of action. Here is a paper by Bedney and colleagues published in 2008 called Concepts Are More Than Percepts, the case of action verbs. In that paper, Bedney and colleague looked at two distinct types of verbs and nouns associated with motion, verbs and nouns which are not associated with motion, low motion verbs and nouns, high motion verbs and nouns. And they looked at the activation of two areas in the brain which are involved in the perceptual representation of motion, namely MT, right and left, and STS, the superior temporal sulcus, right and left. So MT is dedicated to the perception of basic motion in general, while the STS is one of its functions is a perception of biological motion. And as you can see on the graph here, there is in fact very little difference between high motion and low motion verbs and nouns. Right? So difference which are found not in MT but in STS are between verbs and nouns. So it's a syntactic distinction rather than a semantic distinction between high motion verb and low motion verb, or high motion nouns and low motion nouns. Again, it suggests that the thinking about verbs and nouns which are more or less associated with motion does not produce any difference in the superior temporal sulcus and MT, namely in areas dedicated to the perception of motion, which suggests that concepts of motion, concepts of actions in particular, just are not perceptual concepts. Another way to try to get at this question is to look at the concepts of actions of people who, for people who've never been able to see, namely people who have been congenitally blind. And what one finds in this case, when one compares sighted and people who have are congenitally blind, is that there is in fact no difference between the representations of actions among these two populations. That's what you can now see on the screen. Now that's striking because if the empiricist picture of concepts were right, we would expect the concept of action of sighted people to differ from the concept of actions of blind people. After all, sighted people have had extensive experience in seeing other people and themselves acting, and their concept of action should include perceptual, namely visual representation of action. That's not what we find. Now, moving beyond concepts of representations of numbers, concepts of action, what about concepts of mental states? So we've learned that mentalizing, thinking about other people's beliefs, desires, and other mental states involve a network of area, a part of which, and part of this network is a right temporal parietal junction, the RTPG. We can apply the same kind of ideas looking at the activation of the RTPG in people who are sighted and people who have been blind since birth. And again, we find the same result. We find that the theory of mind, or the mind-reading network, is identical among these two populations. Bedney and colleague in a 2009 paper conclude that the development of neural mechanism for theory of mind depends on innate factors and on experiences represented at an abstract level, amodally. Right. And what you can see here is the data involving the right temporal parietal junction among sighted and early blind individuals. And as you can see, the activation are extremely similar, suggesting again that the concepts here of mental states are amodal concepts rather than perceptual concepts. If they were perceptual concepts, we would be expecting differences between these two populations. Let's move now beyond neuroimaging evidence toward neuropsychological evidence, and we're going to look at dissociations between the capacity to act and the capacity to think, looking, for example, at artifact concept. The thought here is that artifact concepts should involve the capacity to manipulate this concept, should thus involve motor representation of artifacts. on the empiricist picture, to have a concept of a hammer is includes a motor representations of how to use that hammer. If that's true, then we should not find double dissociations between the capacity to recognize hammer, which manifests the use of a concept, and the possession of a concept of a hammer, and the capacity to use that hammer. However, what you can see in this paper by Machery and colleagues, and there's actually by now many other papers by Bradford Mahon that support the same claim, what you can see here is a double dissociation between the recognition of artifact and the use of this artifact. Patient DM, CE, and PI, for example, are able to use a concept, but they're unable to recognize it, while patients FS, RO, and BL have the opposite dissociation. They're able to recognize artifacts, they're unable to use them, suggesting that the concepts of artifact are not made up of motor representations. Again, something that is at odds with natural predictions from an empiricist approach to concepts. The last piece of empirical evidence I want to mention in neuropsychology is the work on semantic dementia, and I talk about that in a paper with Joseph Machery published in 2012. You can see the citation on the slide now. So semantic dementia is a dramatic disorder which involves the progressive loss of all conceptual resources. And it starts by a disorder on the anterior poles, and then it's spread throughout the temporal lobe. Now, neo-empiricist and Amodal approach made two distinct predictions about the pattern of conceptual loss to be observed in people with semantic dementia. On the one hand, neo-empiricists predict a modality-specific conceptual loss. So people with semantic dementia should lose the capacity to think in vision, for example, and then lose the capacity to think in auditory terms, and then lose the capacity to think about proprioceptive terms, right? So the conceptual loss should be modality specific. By contrast, Amodal theories predict a modality general conceptual loss. It predicts that patients with semantic dementia will not lose their concepts in a modality by modality. Rather, they will lose their concept independently of modality. And what we find when we look at the evidence is that the Amodal prediction happens to be the right one. So what we've seen here is a growing body of evidence coming from behavioral data, neuroimaging data, and neuropsychology, and there's much more, which I didn't have the time to talk about, that suggests that the concepts that we use to solve various tasks are in fact distinct from a perceptual representation. They are amodal. To conclude this talk, I want to briefly mention the offloading hypothesis. And given my views about the nature of the brain as an amodal system, I'm faced with the following puzzle. It is the case that some evidence suggests that perceptual representations are indeed involved in conceptual processing. So I do not want to deny that people working from a neo-empiricist perspective have indeed provided really strong evidence that at least sometimes we do use perceptual representations to solve tasks involving concepts. A nice example comes from the work of Rob Goldstone at Indiana, who has shown decisively, in my view, that to compute arithmetic operations such as addition or subtraction, we use very simple visual cues, such as a distance, such as visual grouping, the distance between signs on a screen or on a sheet of paper. And when we disturb these visual cues, people lose or people's capacity to compute these arithmetic operations is impaired. So how to make sense of the view that concepts are amodal, but that we nonetheless use perceptual representations to solve various tasks that involve our concepts? Well, what I want to put forward is what I call the offloading hypothesis. It's a view that concepts are indeed amodal, but to the extent that we can, we offload the solution of tasks on perceptual and motor systems. Right? So while concepts themselves are amodal, we often manipulate perceptual and motor representations to solve tasks. Why do we do that? Well, for a variety of reasons. It may well be that offloading is an efficient strategy in many circumstances, right? Or it may be that it's a fast strategy, or it may be that in familiar context it's the best strategy, and so on and so forth. So details of the offloading hypothesis here have to be investigated in future research. But what is important for me here is that accepting that the brain may well be an Amodal system leads us to view the involvement of perceptual and motor representations in a new way and to ask new empirical questions about their involvement in thought. Instead of arguing that concepts are perceptual, we now want to get an understanding of why or when, in which context, we use perceptual and motor representations in order to solve various tasks. I think that should be the future of the debate between empiricists and Amodal theorists of concepts. To conclude, I want to argue that by and large Descartes was right against Hume. Concepts are indeed Amodal. That does not mean that we do not use perceptual and motor representations in thought. We do, and the offloading hypothesis is meant to capture that phenomenon. It's meant to raise empirical questions. But concepts themselves are Amodal. If you are interested, here are some papers where some of the views are developed. In 2007, I focused on the limitations of the work done by empiricists. In 2012, I've looked at neuropsychology to argue for an Amodal view of concept. And in 2016, I've reviewed the empirical evidence in favor of the Amodal brain hypothesis, and I've put forward the offloading hypothesis. Thank you for your attention.